Alright, let's look at solving a system of equations by using substitution. Now, substitution is basically to replace a variable with another value or another variable. So you may substitute either equation, but it's best to use the equation where the variable is already isolated. So basically where the variable already has a coefficient of 1. Or it's y equals something or x equals something. It's already solved for that variable. So let's look at some examples. Okay, in the first one, we need to find the solution for the system y equals negative 4x plus 12 and y equals negative 2x. Notice, you've already got both equations are already solved for y. So we're going to substitute for y. So if I take the first equation, y equals 4x plus 12, I'm going to substitute negative 2x, which is right here with using the second equation, for y because it equals y, and then solve for x. So I ended up coming out with negative 2x equals 4x plus 12. Okay, now let's solve this. Now I don't really need to move the negative 2x because that's the only thing over here. I want to move this 4x over with the negative 2x. I do that by subtracting 4x from both sides. Negative 2x minus 4x is negative 6x. And then on this side I'm left with 12. Okay, now we just divide each side by negative 6 and you get x equal negative 2. Well, now that you know one variable's or number or solution, you're going to take that number, and since we know x is negative 12, we're going to plug it in the x value into either equation. It doesn't matter which equation, you're going to get the same y value and solve for y. So I've done it both ways, using both equations, but you only have to do it with using one of them. Now if you use the first one, you're going to do y equals 4x plus 12. In for x, you're going to plug in negative 2. So y equals 4 times negative 2 plus 12. 4 times negative 2 is 8. Or, excuse me, negative 8. And negative 8 plus 12 is 4. Now let's just double check. Let's make sure we've done this right. And it's the same if I plug it into the second equation. So I have y equals negative 2x. I do y equals negative 2 times negative 2. And negative 2 times negative 2 is 4. So notice both of them is going to give me the same answer for y. Now, when I write my solution, I'm going to write it as an ordered pair. I know my x value is negative 2, know my y value is 4, so my point where the two lines intersect is going to be at negative 2, 4. And there's my answer, is just that ordered pair. It's where the two intersect. Okay, let's do another one. This time I have 4x plus y equals negative 2 and negative 2x minus 3y equals 1. Now notice, neither one of them is an x equals or a y equals. The variable isolated all by itself. So sometimes you have to solve for that variable first. Notice in the first one I have just a plain y. There's not a coefficient, it's not a 2y or a 3y like it is over here. This y is all by itself. Like it doesn't have a coefficient with it like the 4x does, or the negative 2x or the negative 3y. So what I'm going to do is I'm going to take that negative 4x plus y equals negative 2 and solve for y first. So if you do that over here, I subtracted 4x from both sides to get y to equal negative 4x minus 2. Now I can easily put in negative 4x minus 2 in for y because that's what y equals. So I take the first equation, after I've done this, I take it, use the second equation, negative 2x minus 3y equals 1, and plug in this expression right here in for y. Notice since I'm multiplying y by negative 3, I put it in parentheses because this whole thing has to be multiplied by negative 3. Alright, so that gives me negative 2x minus 3 times, and it's in parentheses, negative 4x minus 2 equals 1. First thing I need to do is distribute. So negative 3 times negative 4x gives me a positive 12x. Negative 3 times negative 2 gives me a positive 6. Notice I still have my negative 2x. Now I need to combine like terms. Negative 2x plus 12x is 10x, and then I still have my plus 6. I solve for x, so I subtract 6 from both sides. Get 10x equals negative 5. Divide each side by 5, and I get x to equal negative 1/2. Now I take my x value and plug it into either equation, the first or the second. I've chosen to do the first. You can choose to do the second. You should get the same answer. Alright, so I take 4x plus y equals negative 2. I take my x to equal negative 1, negative 1/2, put that in for x. So 4 times negative 1/2 plus y equals negative 2. Solve for y. 4 times negative 1/2 is negative 2, plus y equals negative 2. Add negative 2 to both sides. Notice those cancel out, and notice negative 2 plus 2 is a 0. So y is going to equal 0. So my solution in this problem is going to be negative 1/2, 0, and a coordinate point in parentheses. And that's where those two equations are going to intersect. Alright, let's do one last example. Actually, two last examples. Excuse me. So we need to solve this system. X minus y equals 1 and x equals 1/2 y plus 2. Notice this second equation is already x equals. So I can use it to plug it into the first equation. So I take the first equation, x minus y equals 1, plug in 1/2 y plus 2 for x. Notice I went ahead and put it in parentheses, so I know that's what I'm putting in for x. Okay, so I need to combine like terms because I got two y's here. Okay, 1/2 y minus a 1y, that gives me a negative 1/2 y. Then I still have the 2, no other terms on this left side to combine it with, so I still have plus 2. Got minus 2 from both sides. 1 minus 2 is negative 1, so I get negative 1/2 y equals negative 1. Now, to get rid of and move the negative 1/2 to the other side to solve for y, you can do one of two ways. You can divide by a negative 1/2 or multiply by a negative 2. Same thing. I'm just going to go ahead and multiply by negative 2 on both sides. I get y to equal 2. There's my y value. Now I need my x value. Take my y value. Either equation doesn't matter. Since this is an x equals, solving for x, I'm going to use the second equation. Make it a little easier on myself. So, I plug in 2 for y. I get 1/2 times 2 plus 2. 1/2 times 2 is 1, and 2 and 1 added together gives you 3. So my x value is 3. So my solution is, remember, x is written first, so it's 3, 2 is my solution for that system. Alright, this second system that I'm solving is y equals 2x plus 5 and y equals 6x plus 1. Since they're both a y equals, you basically set them equal to each other. So I get 6x plus 1 equals 2x plus 5. Because what I've done is taken the first equation, plugged in 6x plus 1 for y, and basically equal each other. Alright, x is to one side, constants to another. I subtract 2x from both sides. 6x minus 2x is 4x. That goes away, so I still have 5. 4x plus 1 equals 5. Subtract 1 from both sides. I get 4x equals 4. Then what I'm going to do is divide each side by 4 to get x equals 1. Okay, now that I know x equals 1, I'm going to take that, plug it in for x into one of the equations. It doesn't matter which one, and solve for y. So, y equals 2x plus 5. I'm going to use the first one. Plug in 1 for x, so I get 2 times 1 plus 5. 2 times 1 is 2. 2 plus 5 is 7. So I have y to equal 7, x to equal 1. Remember, you write your x first and your y in your coordinate point. So my solution is 1, 7. Remember, we write those with parentheses on either side.